Thanks all for joining. We'll be starting in few minutes. We are waiting for other folks to join. Yeah. Mr. Sheikh, is your students already joined?
The Giants are two people
Fine, no problem.
waiting for two
Okay,
people. Sir.
yeah,
Four
fine.
people already
You
joined.
can you can respond in chat.
Oh, okay,
Yeah,
sir.
thank you. Okay, fine. So let us start the session. I'll just take a control and then we'll try to jump into this um, massive project which we are going to discuss today. Let me quickly share my screen. Mm, yeah, I screen. Okay. So I hope you all are able to see my screen. So let us begin with um, understanding our course curriculum. So this is, I am Rahul, and along with me, I have my uh, trainer Kallol with us. So he is we both are DevOps consultant here. I'm in US, Kallol is in India, and then we are teaching DevOps related stuff in AWS and in Azure from long time. Our company do that. We both teach things in AWS, and then there is another trainer who is Venkat who teach things in Azure. We are expert in DevOps related um, skill set. Our company generally only teaches DevOps related stuff in Azure and AWS. Okay, so having said that, we come up with a very good idea of teaching things in a project based manner. Okay, so we do have all the courses which will be there in project based. So if you go to these courses, okay, so you will get here an L2 course. This L2 course is going to give you an experience so that you can become an L2 professional and can work like an L2 guy. Okay, so if you click on this project curriculum, okay, I'll just share this curriculum to all of you in the chat window. Okay, so this curriculum says that this is around 30 hours, which will be approximately taking, we are saying less time, but then it will take more time. 35 hours minimum it will take. Okay, 35 hours minimum it will take to complete all these projects. It may take, depending on students, 40 hours, but then maximum will complete everything in 40 hours. So in this 40 hours of knowledge transfer session, when I say KT means knowledge transfer, where we are going to transfer our working knowledge, whatever we work in a company, will transfer our knowledge to you all, wherein we'll cover 20 minor, 4 major projects, and one capstone project. In this, you will get around 3 years of working experience. Okay. With this experience, you can create your CV. Okay. Once you create the experience, you will be create your CV, you will be implementing your CV with us, and then you will start applying for job. This is a 3-step process which you have to follow. This is the easiest way to crack a job in IT without any development related knowledge. Means without any Java, Python, and all this knowledge. It is the easiest way, believe me. So that is the reason we say there is no coding language required. We'll cover multiple projects. Okay, approximately 30 real-time projects, wherein mainly minor, many major projects will be there. So we'll cover that. What is like major project, what is minor project,
Hello,
and
hello.
all those. Let me remove the unmute access. Okay. Those who have any doubt, please raise your hand. Let's maintain the decorum. Okay. Fine. It's a job ready course. Okay, where we say that as we will be giving you CV. Okay, CV will be given to you on the Slack channel. So we, for each and every course, we will create Slack channel, and there we will be giving all the notes, the CV, so that you can create your own CV and start applying for job. Okay, like this, we'll give CV to you. This CV will be like day after tomorrow only. We will be providing you this CV, so that once you have enrolled for the course, this CV you can take, and then this is your Bible. Now your task will be to complete this whole, all the things whatever is mentioned in this particular CV, so that you can implement the project and then get the experience. That's the basic thing which you are going to do. So I would like to introduce you with our trainer Kallol, who is going to train you this project. The project diagram will look like, basically we will try to explain you a project where we'll try to cover Kubernetes. Okay, um, we'll try to cover Ansible. We'll try to cover the monitoring tool. Basically, whatever is required for you to get a job. Start from provisioning, start from configuration, start from orchestration tool, monitoring tool. All these things we'll be covering with the help of multiple real-time projects, so that you get that experience, get the confidence to crack a job. The whole course is all about this. I would like to welcome Mr. Kallol. Kallol, you can take over and start your session. Thank you.
Hello, everybody. I'm Kalol. I'm going to be your DevOps trainer on this AWS cloud platform. And well, Rahul has already given the brief introduction. So let's get into the real-time thing, what we are actually going to accomplish. So I'll give you an idea. So this is just a sample, one of the many architecture diagrams that we will follow. And well, this is the course. It has got multiple projects. Multiple projects will gradually we will be getting accustomed to various tools. So I'll not be discussing each and every tool here. That is anyways not possible in such a short time. But nevertheless, you will get a fair amount of idea what you are going to get into. So let me start with a slideshow that will give you an idea like what is this course about. Right. So let's go through the glide path here. Let me switch on my pen. So this is a CI/CD based automated DevOps project. It's actually plural. There will be multiple projects here. We will be using various architecture diagrams here to understand. So CI/CD. So yeah, you will be coming across various new terms. So don't get overwhelmed. Gradually over a period of time, you will start understanding this stuff. So CI/CD, basically here it means continuous integration and continuous. So CD has got two things. It stands, CD can mean, C is for continuous. The D part here can be deployment as well as delivery. We will see what the difference is. So we are going to focus on the deployment part here. And it will all be automated. So what is your continuous integration and continuous deployment? I will showcase a few things practically as we move ahead with the session. So the idea here is you are going to build, when I say you, it is the entire team I'm talking about, a software team. Okay, so there is software development that happens. Basically, developers write code. This is the development team that writes code. But then in a team, there are not only developers, we have various job profiles. So there will be developers, there will be testers, and then there will be the operations team. So usually in the DevOps world, the testers and the IT operations team, they together are called operations or the ops team. Okay, developers will write code. That code can be for two specific tasks. Either they are building something new, some new feature, maybe a drop down, maybe a button, maybe a list, adding a new web page. So either they are going to write code for new functionality, or they are going to work upon existing functionality. Okay, so or they are going to rewrite code. So alter something existing. So that can be something maybe related to a bug fix, or maybe something else, which the code already exists, they are working upon it. So now once the code is written, it needs to be released. So for look at this loop here. It's a continuous loop. As you can see, it is a continuous cycle. So a software is released, it is deployed. When we say deploy, that means we are putting it into a system where actual users are going to use it. But before the users can use it, it has to be tested. So there are various. So we will come across something called the concept called environments, ENV. Okay, so you have got a development environment, you have got a test or staging environment, and you will also come across something called oops, sorry about that. So I'm not getting space here. Hang on. I lost my pen. One second. Yeah. So you will also have something called, the most important is something called prod or production environment. We will come across these words. I will explain. So this is the first session. So you will have a lot of jargon, a lot of new terms. So don't worry about this. As I proceed further in the course over a period of time, you will get used to it. You will understand. I will also be explaining each and every line of code. So, oh, sorry. One thing I forgot to explain here. So after the deployment, it also needs to be operated and monitored if everything is working fine or not. So by the time when you are monitoring, that means you are actually checking each and every server, each and every application, if they are working properly in the production environment. That is where users are actually going to use it. Okay, that's one release. So usually that comes as with a version. So maybe release 1.0. But then after release version 1.0, then the team comes back together, basically serving the actual customer who is sponsoring the project. Now they might have a new plan. Maybe they want to add new functionality. So then again, that cycle will continue. Again, new code will be written, new code will have to be built. And then again, it has to be tested, and then again a release. And this cycle goes on and on. So once you have created a software, it does not end there. That is why it is called SDLC. Software development life cycle. It's a cycle. It goes on and on. Once the software has been developed and built, it also has to be maintained. And that is the place where, as a DevOps engineer, your role will be. You're going to support the developers, testers. So I will explain that shortly. So this was a very brief overview. I'm going at a very fast pace here, just to give you a basic idea. But what I'm trying to explain here now is what are the things you are going to, giving you a very high level overview, what you are going to learn as part of this course so that you are job ready. So initially what we will start with is we will learn to build and deploy code on something called Tomcat. Okay, so Tomcat is an application server. I'll just write it in short. It's an application server. This is where your code will be hosted. But for that, we will need to use various tools like Git, that is not mentioned here, but then Git, Then there will be a repository where the code will be stored. That is your GitHub. We will be using Jenkins. Jenkins is your, I'll explain that shortly. It's your CI server, continuous integration server. We will need a build tool. We are going to use Maven. And then finally, the website or your web application will be hosted on an application server called Tomcat. So the way we are going to do things, this will be sort of, there will be a repetition here. The repetition will be in the format, how we are doing it. First, we will understand what the tool is at an individual level. Okay, what the tool does. Then we will manually do the steps first. There will be a step where we have to provision the things. When I say provision, that means if a software has to be installed, for example, Tomcat is a software that has to be installed so that you can run the web application, but it needs to be installed on a computer, right? We can call it a machine, a node, a server. In our case, we are actually going to refer it to as EC2. What EC2 is, I will shortly discuss when I discuss the AWS cloud platform. So we are going to install the tool. So we will be doing things manually first. So that manual part involves provisioning. After provisioning, so as part of the provisioning, there will be installation here. But it does not end there. After the install, you have to configure it. And after configuration, you will have to integrate it. I hope you are able to read my handwriting, and I apologize, it is a little bit ugly. And then finally, after the integration, you will have to automate this complete stuff. Okay, so as we keep proceeding, newer tools will getting introduced every time. And you will have to go through the same cycle, have the tool, manually provision it, install it, configure it, integrate it, and then automate it. Okay, so this will be something that we are going to do. And you have the syllabus with you. I'm just breaking up the syllabus here, what exactly, and it is going to be incremental. We are going to do it in stages, one upon the other. It is going to layer by layer. We are going to proceed towards our goal of automation, of doing the entire CI/CD, continuous integration and continuous deployment. So people who are absolutely new to this, it might sound overwhelming to you, but give it some time. It will be a very good learning experience for you because we teach things from scratch, and we are going to also we are going to learn something called Linux. Okay, so that is an operating system. That is the core operating system that you have to use for any DevOps profile, any DevOps CI/CD. Okay, so as part of this, as you can see, we are going to set up Jenkins, set up and configure Maven and Git. So here I will like to mention that Git and GitHub, they are not the same thing. We are going to set up a Tomcat server. And then this part is important. Like every time you will be seeing this integration. Okay, and then post this integration. So you are integrating all these softwares together. So in the first project, we are going to deal with GitHub, Maven, Git, Tomcat, and Jenkins. Jenkins will be there all around. Throughout the entirety of the course, we will be giving multiple Jenkins builds, and layer by layer, project by project, with starting with mini projects, you will gradually get to know how to create an entire CI/CD job in Jenkins. And then, of course, you have to, before you can release it, you have to test and automate the deployment. Cool. So let's have a diagrammatic view in pictures. How does it look like? So how do we deploy Artifact? So Artifact is something that is going to be a product of our build. This is, when I say an artifact, this is what will actually contain the code, the final code. And using that final code, our website will be up and running. I'll show you some live examples shortly. So the first project major project will be related to the Tomcat application server. So how it will be is you will have something, you will start with something called Git. Git is source code management tool, SCM. Okay. Using Git, you will be able to manage the code. So it will have its own session. As we proceed, you will see. But if, I mean, like, get used to these names and the images that I'm using. These are the trademark images. So you should, just looking at the image, you should be able to identify in future what tool we are referring to. So Git is a source code management tool. This is what the developers will use to, very simply put, they will write their code, but then they should be able to share their code also at the same time without affecting other developers' code. It is not that only one developer will be writing code. Multiple developers will be writing code. So at the same time, they will all be knowing what each other's code is. But at the same time, they will also be writing their new code. That is what this Git tool will do. So they will use Git to write code and share code. And then they are going to push that code. You have to push that code somewhere. So that where it is going to be pushed is called GitHub. Okay, it is a code repository software. We call it code repo, remote code repo. Why is it remote? Because it is accessible over the internet. Okay, so that is the reason why I was emphasizing Git and GitHub are not the same thing. Without Git, there is no GitHub. We are going to use both of them together. And individually, I will be explaining each and every tool later on. So this is again a very high level overview. So once the developers have written their code in their local machine, that means in their local system, I'll call it, it can be a Mac, a Linux system, or a Windows-based system. Whatever it is their local computer. From there, via the internet, they are going to push the code into GitHub. That is going to be the remote repository. Now, because it is over the internet and it is hosted on a website, okay, it will be remotely available to everybody, all the other developers. Okay, they will be able to pull the code. So if an individual developer is pushing his or her code into GitHub, the other developers will be able to pull it. And that is how they will synchronize. What happens after that? The code is, so, okay. I will show you real-time GitHub examples, and then you will realize. So it is not just one file. There will be multiple files and folders. They together constitute in its entirety what is required to actually have a functional website or a functional web application. Cool. So what after GitHub? Let's see. Now we are going to get into Jenkins. So this is another software. Again, this will be, we will have to do the installation, the configuration. There are a lot of things that you have to do, but basically Jenkins is something called a CI server, or it is your continuous integration server. This is the main tool that will integrate all the moving parts here. Later on, there will be other softwares on other machines installed, and how they will communicate with each other, which file needs to be transferred to whom, who will log in as a user into a different system and do what. That is all that will be controlled via this server, this software called Jenkins. It is also a server actually, and hence the name CI. So this part, Jenkins is going to take part of the CI part, CI/CD, because don't forget, our DevOps, this cycle, okay? You will code, you will release, you will code, you will test, you will release, you will deploy, you will monitor, and then again, you will go back to planning, again write code, and then this cycle goes on and on. Okay, so this is where Jenkins stands out as a unique software, which helps us in the continuous integration. So what after Jenkins? So Jenkins is basically going to pull the entire code base from GitHub. So by this time, what has happened is multiple developers So I'll just call it developer 1, developer 2. So let's say there are 10 different developers in a project. All of them have used Git and they have written their code, and all of them have updated it in GitHub. Okay, we will see there are Git commands that you will learn how there will be a final branch in GitHub that is usually called main, or in other words, also referred to as production. Okay, whatever code lies here, that is what actually users will use. Jenkins will pull that not only from the main branch, but from other test stage, other branches also. Every time in any branch code is updated, Jenkins will pull that and it will integrate it with the rest of the software. And then how does it do that integration? Let us see. The developers for implementing a web app, they will have multiple files. Okay, so maybe like file 1, file 2, ... file n. And there will be other folders also. Basically, every code base looks like this. It will have files and folders. The file types will be different. Maybe the developer is writing code in Python. Then the file will end with .py. Maybe the developer is writing a Docker file. It will have a Docker file extension name. There will be Jenkins file. There will be multiple files here. Our code base, I will share that code base with you. It will be Java based. Okay. So for Java based projects, so developers will usually write in code in multiple languages. There is something called 3-tier application. I will discuss that later on. So any modern application is built on 3 tiers. There is something called a presentation tier. This tier is what usually the users will access. Then there will be application tier, and there will be a database tier. Okay, so developers will be writing code in multiple languages. They can use Python, they can use JavaScript, they can use HTML, Java, C#. The list is literally endless. Jenkins needs to collect all these files and folders with different file extensions. And then it is going to, depending on the programming language, different tools are used to build the code. Remember here, developers are going to push multiple files. Okay, but then these programming, the files that they have written, they are written in high level programming languages. What I mean by that is they are human readable. We write that code, we understand that code, but machines do not understand high level language. Any computer, so anything can be a computer. Your mobile phone is a computer. Your an ordinary calculator you are using is also a computer. Your laptop, PC, anything, a smart TV is a computer. It has got a chip inside it. So any computer only understands binary code. What I mean by that is it will understand only things in 1, 0. Okay, it is basically a string of 1 and 0. Either the switch is on or it is off. There is nothing more than that. Beyond that, no computer can understand. So depending on your code base, for example, in this project, in this course, I'm going to use, it is a Java-based project. Depending on the programming language you are using, your build tool will vary. So for Java-based projects, there are various build tools. The most popular being something called Maven, Apache Maven. So Maven is the name of the tool and Apache is the name of the company. So Maven is going to be our build tool throughout the course. Okay, so what Maven will essentially do is out of all the number of files. So let's say developers have written, they have pushed their code base into the GitHub code base. It consists of more than 50 files, 50 plus files are there. So Jenkins will collect all those 50 files and give Maven. Now, because this is a Java-based project, that is why I'm going to use Maven. Maven will collect all those files. And then when I say it is a build tool, what is it building? It is going to consolidate all these C plus files and convert it. It is going to archive it, which essentially means there will be only one file. And that file will be a special file. It will be in binary format. Because if it is not binary, as I said earlier, computers will not be able to understand it. And hence they will not be able to deploy it. So there will be a single binary code file that will get generated. You will come across this name later on, webapp.war. Web is web, internet, and then app is application, and war stands for web archive.
So
Yeah, I think
so guys, here, just to interrupt here a little bit, just to explain what exactly this particular thing he's trying to explain, that think that this is kind of a manufacturing unit, okay? So where a lot of manufacturing units are producing lot of, there are a lot of raw materials, and then with that raw material, what Jenkins is doing, it is assembling it and creating the final product, which is your war file. So creating that final product, which you will be now shipping it to the showrooms so that they can sell it, okay, so that customers can consume it. So that particular thing is your that artifactory, so which is what Kalol is explaining. Okay, so I thought that maybe I'll jump in so that little voice
Cool.
things will
Thank you.
change so that people will be focusing more, okay? Because yeah, okay, so
Yeah,
guys,
it is
if you
getting
have any
complicated, I
doubt,
know.
please ask questions on the group chat, okay, on the Zoom chat. I'll try to answer all those questions.
Right. So in continuation, this is one of the samples. People are asking if there are we can use jar files. Yes, we can use jar files. Jar is again, so when there are Java based projects, you will have .war files, that is web archive, .jar Java archive, and .ear, okay, enterprise archive. So yes, multiple. So Jenkins does not only deal with Java. You can, if it is a .NET project, then you are going to provision. So in this case, we are going to use Linux-based machines. Okay, I'll deal with operating systems later on. There is a little bit of quite a little bit of things that I have to explain there. So all the things cannot be discussed at the same time, but it will gradually proceed. I'm again giving you only a high level overview, what the projects would be, so that you have a very like a 10,000-foot view, like exactly what you are getting into, what these various projects will be. This is one of the major projects that we are going to do. This is the starting point. So yeah, developers can use Python, Ruby on Rail, different kinds of artifacts will, depending on the programming language, your tool will be different. So if you're asking that, can we use Apache? Apache is not a tool. It is the name of a company. Apache has got various tools. There is Apache Spark, Apache Tomcat, Apache Maven. Depending on your project, which tool you are going to use, it will depend. And the file format for Java-based projects is usually war and jar. Okay, zip is used for other like HTML-based different kinds of. Again, it depends. We are getting into micro here. It will depend on the programming language that you are using, how you are provisioning. Having said that, keep in mind the same thing can be done in multiple ways. Okay, so we have, but here let us get back on track here. The main thing is
Kalol,
we have
Ganesh is
created
having
this.
one doubt. Ganesh is having one doubt. He's asking me to unmute. So Ganesh, I requested you to unmute. Do you have, like, just to complete this slide, Ganesh, have you got the unmute access? Yeah, go ahead, Ganesh.
Sir, we are working in WebSphere technologies, but we are also
Uh-huh.
migrating my servers. So
Okay.
in this case, what will any guidelines?
So I'll tell you, very easy. Is it
Okay.
WebSphere? It is WebLogic. It is Tomcat. It is JBoss. Doesn't matter.
Okay.
Glassface doesn't matter.
Okay.
Okay. It is your application software. where you will be deploying things. So the tech stack doesn't matter. So these are all called tech stack. What? Your Tomcat, JBoss, WebSphere. Okay. So finally, what exactly we have to do? You have to follow this whole thing like Git, GitHub, Jenkins, which Kalol
Okay.
is explaining. Git, GitHub, Jenkins, Maven. Final product is created. Correct? The final
Yes, yes,
product.
yes.
Now, what you will do? Your WebSphere is like a showroom. Now,
Yes, yes,
WebLogic is like one more showroom. Now, what I
yes.
will do, I will copy this webapp.war file to that WebSphere. Tomorrow,
Okay.
somebody else will say, okay, copy that to WebLogic. Okay, I will copy. Okay, that's it.
Okay. But
It's like
in my
very simple.
environment, small thing using only cloning and Git cloning and downloading and deploying is the only small thing is going on, sir. Or how to
No, it
download
is
Git
not
clone
small.
like this.
It doesn't mean that how small is your environment doesn't matter.
Okay.
Do you want to do the automation? Do you want to implement the DevOps culture?
Okay.
That matters. Is
Okay.
your
Okay.
company inclined towards the DevOps culture? Yes or no? If yes, we'll follow this. If no, then we'll not follow.
Okay.
Understand, right?
Understand.
Now, ultimately, company, everyone will move to DevOps. Why? Because companies are trying to move to cloud technologies. They don't want to spend more on this manual task. Okay. Now, one guy, one DevOps engineer can do so many stuff. They know now storage, they know cloud, they know Linux, they know Jenkins, they know Kubernetes, orchestration tool. Okay, you might be hearing all those things now. WebLogic, WebSphere, nobody will use nobody will use in the server level. They will containerize it. They will create an image now. Okay, so you will get images of that, and then that in that image only you will deploy. That image is only the build process. Now you can have 20 WebSphere, 20 WebLogic instances. Okay, based on your customer base. How much customer? It depends on like how much load average is there, how much threshold is there. So yeah, so we'll discuss that more. I hope we have answered your question. Again, if anybody have any doubt further, please go and ask in the chat window. I'll try to help. Now we will move to another slide. Sorry, Kallu.
No, it's okay. So in continuation, where we left it was, we finally have our binary file in any system. It does not matter which programming language you are using, what is your code base. Ultimately, when it has to be deployed, it needs to be a compressed binary file. Otherwise, you will not be able to deploy it because machines understand only binary. So moving on, in this case, what has happened is Jenkins collected all the 50 plus files, code files, and then gave it to Maven. Because it is a Java-based project, we are using the Maven tool. Apache is the name of the company. Okay, it has got multiple tools. Now, using Maven, we are finally going to build this webapp.war file. In our case, it is going to be a web archive file. Fine. We have the artifact that is called a build artifact. Okay, what after that? So after that, Maven it produces this war file build artifact, and then there is in Jenkins, whenever you're going to give a Jenkins build, a Jenkins job, it will have its own workspace, something called a workspace. That is nothing but a specific folder where it's keeping all the required files and artifacts. So Jenkins will get this file in its workspace, and then Jenkins is going to transfer this file. So this is on a separate machine. GitHub is a separate machine. Git is on, again, the local developers, the developers local system. Okay, this machine we have to create. That process is called provisioning. Once Jenkins has got this war file, Jenkins is going to give it to another machine. In that machine, we have to install and configure a separate tool called Tomcat. Again, that is from the same company, Apache. Okay, the images that I'm using, these are the trademark images. So kindly get used to this. So once this war file is deployed, we will go through a process of deploying. We'll see how we will deploy it. That is the next step where your website is then ready, or your web application is actually ready. Okay, so that is what this thing is about. This first project is about. But then here this is initially we are going to do these steps manually. Okay. But as I said, in DevOps, the focus is always on automation. Okay. So we have to automate this stuff. So downloading, what is the manual thing we have to do? Manual thing will be like downloading the Tomcat application, then doing its configuration, then doing its integration with Jenkins, and then doing the deployment. So instead of having to download, install, and configure Tomcat, in the next part, when we proceed with the course, we will get introduced to another software called Docker. Okay. So very simply put, Docker, when you hear the word Docker, you will definitely use something called container. Okay. It is a containerization tool. Okay. Using Docker, we will create containers, and for those containers, they are readily available, in which Tomcat will be pre-installed. So Tomcat is just one example. So if you have got Glassfish, these are other softwares. Okay. So in a Linux environment, it is going to, with its own operating system, we are going to use Docker to create containers where Tomcat will already be installed for us. Okay. So for that, we have to set up a Docker environment, and then we have to write a Docker file. In that, there will be specific instructions how to get it configured. We are going to, after writing the Docker file, we are going to create an image out of it. Okay. So an image is nothing but using which you can install something. Okay. Earlier we had been using like CDs and DVDs to install operating systems or any softwares. But nowadays, the concept is still the same. It is still an image. Nowadays, if you install any operating system, you use a USB or you directly download it from the internet. Okay. The concept is still the same. There will be a code file. That file is called Docker file. Using that code, you're going to create an image. Using that image, you're going to run a container. Okay. And that container we will make it run on a particular. So this is going to be another machine, another computer, or another node. And in our case, it is going to be a EC2 instance, because we are going to use Amazon Web Services. Later on, we are again, as I said earlier, we have to integrate this stuff. So Docker node will also, this is a separate machine, right? This Docker node. So we are going to integrate it again with Jenkins. So throughout the course, you will see Jenkins will be a pillar for us, because that is our continuous integration server. And once we have done all of this stuff, manually downloading, installing, integrating, then of course, we have to do the CI/CD, wherein we are automating the deployment. Okay. So how it will vary. So till now we have been through with this image. So focus on this part. Now, instead of having to do this manually, that Apache Tomcat, the entire thing we will replace using Docker. Okay. So it is looking very simple in the image, but there are lots of steps involved here. That is what you will learn as part of the course journey. So this is going to be a major deviation. That is going to be your second major project. Instead of having to manually download and install and configure Tomcat, you will have it pre-built. We will do that stuff using Docker. And then you will see why Docker gives an advantage. For each Tomcat, you will need a separate machine. Whereas the Docker thing you will do only on one machine. So if you want 3 Tomcat servers, that means you will have to install 3 separate machines. You will require 3 separate computers. Instead of that, if you use Docker in one machine, we can have 3 separate containers, 3 separate Tomcat processes running. So maybe Tomcat 1, Tomcat 2, Tomcat 3. Okay, depending on the size of your computer, it can go up to 100 also. It does not matter. Okay, the stronger system you use, the more containers you can create. But then the entire thing will still be in one machine. So you are reducing cost. you are automating stuff here. Okay. So gradually, as we keep proceeding with the course, you will see although it will look more complicated, but actually the work will keep getting easier and easier. That is the whole point of DevOps actually. So this is going to be your second major project. Now, you will, the next software that will come into picture is called Ansible. What's the purpose of this software will be is, like, you have got one Docker machine. Okay. But then if that machine fails, or what if you need more containers, one machine is not able to handle. So suppose you have to handle, let's say, 10 machines, 10 systems. And in what has happened is, maybe you have installed a version of Docker X, version X, software version X. Now what has happened is a new version has come up in the market. So you want to install X.1 and you need to do it in 10 machines. Now, if you do it manually, you have to log into each of these systems and then you will have to do the configuration manually on all the 10 systems. But Ansible is a configuration management. Using Ansible, you can control not just one machine, but you can control 10,000 machines or more. Okay, it does not matter. You will write the code for the configuration to move from version X to X.1 in the Ansible node. And later on, we will use something called YAML. That is the declarative language that is used by Ansible. And we will write Ansible code. That is called Ansible playbook. It is nothing but code. In Ansible world, they call it Ansible playbook. So using one, you will be able to configure multiple systems in the same way. So there will be no discrepancy. All the other 10 or 20 or 10,000 systems, all of them will have the same version of the software. Namely, in our case, X.1. Okay. So if you want to make changes once, so Ansible is actually used for already provisioned systems. Once your systems are up and running, then you want to make changes together at the same time. That is where you will use Ansible. Okay. And then again, obviously, Jenkins will be your integration server. Again, time and again, Jenkins will always come into the picture. So there is a spelling mistake here. I'll rectify that later on. But using Jenkins, again, you are going to do the CI/CD implementation, where you're going to build the code on Ansible node and then deploy the code on a Docker node. Now here, we are going to use single system instances, but in practical world, you can do it on, as I said, if required, 10,000 machines at the same time, instead of manually going and logging into each system and making the changes. So that is where you will get used to this new software called Ansible. So in pictures, if you have to see, this was the last image that we saw. So it was getting deployed on the Docker node. But now the picture will change. Instead of Docker, we will replace it with Ansible. But that does not mean we are not going to use Docker. We are going to introduce Ansible, but then Ansible is going to deploy it on Docker. Okay, it is going to create the image. Earlier, the image and the container both were happening on the Docker node. But now we will create the image in Ansible and run the container in Docker. What all of this means, gradually you will learn. Okay, this is at a very high level. Okay, so now, okay, here there is, I have to add something. Just like GitHub is a repository for storing code. Repository means where you store something. We also call it repo in short for repository. So for storing code, we use GitHub as code repo. Similarly, for storing images, our customized images, just like GitHub is a website, similarly, Docker and Docker Hub are not the same thing. They might be using the same name in the. So Docker Hub also definitely uses Docker technology, but Docker Hub is going to be your image repo. Okay, we are going to store our customized images in Docker Hub. So we will learn how to. So again, there is a lot of integration that we have to do here. And finally, After the integration, we will also have to obviously automate it. So again, Jenkins will come into picture. So we will do all of that. This diagram is a very simplified, watered down version. Okay, it is a very simple diagram which I've drawn. Practically, there will be a lot more complexity than shown in this diagram. Okay, that we will proceed gradually. So now I think I've spoken for a length of time period. And
So let us ask some
Rahul,
questions from.
yes.
I think let us ask some questions. Okay,
Let me
I'll
check the
just give an
chat.
unmute access to everybody. So now we'll take some questions, but before we take a question, I'll ask some questions to all of you. Okay, from this particular diagram only. What do you think Maven will do? Anyone? What do you think Maven will do here?
Create a war file.
Artifacts. It's create
Maven is
artifacts.
a build tool. It is create artifacts.
It is creating artifact. Very good. But then what is this artifact? What is the process of creating an artifact? Do you know what is compiling? Anyone? So let me ask this question. What is compiling? What do you think? What is compiling?
Combining means list of codes or
Sir, it will merge the code, sir.
Converting it into the binary language. So
From
that system
human
can
code
understand.
to
Compiling
binary
means
code,
it
it's
will
converting.
convert from a dot class file to dot var file.
Okay, somebody
if you-
said binary. That was the exact answer. You are converting human readable language files
Into machine language.
one single machine language. Carry on, Rahul, please.
Yeah. So source code to bytecode. It's a very
Excuse
it's
me,
a
sir.
very common interview question. People will ask you, okay, and this is like you should understand this thing. Like, okay, what do you mean by compiling? So human readable, which is like source code to bytecode, okay, which machine can understand. Fine. Now, as the first question was, what Maven will follow? What are the steps Maven will follow? So Maven will validate the code. Maven will compile the code. Maven will package the code. And then Maven can also deploy the code, okay, to the remote repository, to the remote artifactory, okay. That also they can do, or it can directly deploy to Tomcat also in the Maven. Okay, so Maven is a very powerful tool. Okay. So now when you say package, what does that mean? Package means it is going to create the var file or the jar file. So somebody asked, can I create jar file? Yes, you can create. Okay, so now let us ask some other questions. Here you see there is a very again a different interview question. It's a very common interview question which are being asked from our students. What is the difference between Git and a GitHub?
Sir, Git is a package installer, sir. GitHub is a repository, sir. Git is version control protocol system. GitHub is a repository.
Git is a local repository, and GitHub is a central repository.
Okay, what you can do, you all can is like maybe you can raise your hand and then I can select one person and then he can answer. Okay, that will be easier. So somebody told Git. So Git is it's okay. Again, one more question. Git is a utility or a service? So some Sai
Utility.
Sampath raised.
Utility.
Git is not a service. Git's a utility. Okay, understand that Git is a utility software.
Yes.
Okay, utility tool, you can say, but it's not a service. Okay, so what is the difference between a service and a utility? That's a very simple question, but that will explain the interviewer that you have really the basic knowledge or not. If you are saying Git is a service, that's it, gone. Interview is over there. They understood that you don't have any much in-depth knowledge. Okay, just like if they ask you what is the difference between a private and a public subnet from the network point of view, and you are not able to answer that, interview is over there. They understood that you don't have the experience. Again, Guys, just to before you ask us question, we'll explain you that we are not someone who will who is saying that you should go and do certification and other things. Okay, we are someone who believe in real training, the not the certification based training or not the topic oriented training. It's a project based training. So we'll have multiple projects, okay, and the real stuff, not certification. And interview questions we'll be giving you, and then like this we will be asking you some interview questions. So now here you see there is something called Docker Hub which is mentioned. Okay, what is this Docker Hub is called in company? If suppose if you are working for AWS or Azure, okay, what we will be calling this Docker Hub? Anybody? We'll call it as registry. Okay, we'll call it as registry. All these things you need to know. Where we will push the thing registry. One more thing, Kallol explained a very good thing that you know that there will be we will create the var file, we'll build the var file. In case of container or microservice architecture, what will you build? Okay, what will be your final build artifact? Can anybody guess? I know I'm asking a little difficult question, but then can anybody guess? Okay, in case of
we can build the image, sir.
We can build the image. What will be the artifactory storage there? So those who does the first question was in case of microservice architecture, what will Jenkins build? Jenkins will not build var file. Means it will build var file, but then that var file building is one of the process. But then there will be the final product which Jenkins should build is the Docker image or the image. Now, if the final product is Docker image, what will be the go down for that image? What will be the artifactory storage for that image?
Docker Hub.
Docker Hub.
Docker Hub.
Docker Hub. It should
Docker
be registry. It
registry.
should be registry. Okay. In this case, it is Docker Hub. But then in your company, you may not use Docker Hub. When we teach you, we will not, maybe we might not use Docker Hub. We'll use ECR and show you. Elastic Container Registry. Okay, which is a AWS service. Okay, so we'll try to go to see it's a combination of, you can say, DevOps on AWS and AWS DevOps. Why? Because we are going to use multiple AWS services. Okay, and then we'll also do a lot of infrastructure as a service like also use a lot of open source tools. Okay, which is built for infrastructure as a service. So it's kind of a mix and match, real kind of scenario. We'll try to build whatever we have worked on, and we'll show it to you. And then it is your
one thing,
responsibility.
Rahul here.
Yeah.
I mean, like you use the word
Mhm.
open source. So quickly, just a brief idea. Git is an open source tool. GitHub is free to use, but not open source. It is free to use to a certain extent. It is a paid service. Jenkins is a truly open source tool. Apache Maven is open source. Docker Hub again is free to use, but then it is also a paid service. If you want to have private repositories, it is paid. Same thing in GitHub. Ansible is free to use. It is open source tool, but it is actually just like Maven is owned by Apache. Similarly, Ansible is actually owned by Ansible itself is open source, but it is maintained by Red Hat. And Red Hat has got an enterprise version, which is more advanced of the Ansible version. That is called Ansible Tower. That is a paid. They have changed the name. I think they call it Red Hat Automation Tool now. Ansible Automation Tool. So again, that is paid. So there will be most of the things that we are going to use will be all actually, apart from the Kubernetes, Elastic Kubernetes service from Amazon, rest all of them we are going to use either open source, which is completely free, or the free version of it. Just to give you an idea. Kindly continue, Rahul.
Yes. Okay, fine. So, if so, they may ask you in your interview one interview question that, can you explain your architecture, your CI/CD architecture? So you need to explain them the CI/CD architecture, the flow diagram, okay, like how it flows, that developers will push the code to GitHub. So I asked, what is the difference between Git and GitHub? Git is a utility, a tool through which you can push the code to GitHub. Okay. What is GitHub now? It's a remote repository. Okay. It's a remote repository. Fine. Now, apart from GitHub, do you know any other tool? So it is like GitLab, Bitbucket, all those things. Okay. So you can say those things in your interview. Apart from Jenkins, is there any other tool? Code build. Okay. Code pipeline in AWS, you can use those things.
Maybe CI.
Fine. Yeah. So Nexus repository is a different repository for Artifactory. Okay. So you can use that. It's kind of like Docker Hub, Circle CI. Yeah. Okay.
They are doing the same thing. Whatever
Same
Jenkins
thing.
is doing, they're doing the same thing. So
And
just
then
like if
we
you
will
have to
be
write something you have to type something, you can type it in Notepad, you can use Microsoft Word, you can use Google Docs. Does not matter. So we cannot keep jumping from one tool to the other. Otherwise, we will never be able to complete our project. So in our case, we are, TeamCity is also there, but all of them are not free. Jenkins happens to be one of the most popular continuous integration tool. Why? Because it is open source, completely free to use. Yeah,
okay.
please carry on, Rahul.
And one more thing here, you see, I just wanted to show you all, okay, because I want you all to join tomorrow. But then, as this is a free demo, a lot of people will join on the first day, not on the second day. Okay, so just wanted to show you all that. Okay, this is a flow diagram, guys. That an application which we will try to build here. We will try to create
I think you are not
something.com.
sharing your screen, Rahul. Do
No, I'm not
you want to
sharing.
share your screen? No.
Okay, I'll share
Kindly.
one more time. Okay, now is it?
Yeah. No. Yeah.
Okay, fine. Here you see. So I just wanted to show you this diagram where you see there will be some website we'll try to build, like maybe lwplabs.com. Okay, in which we can get things from GoDaddy. This .com we can get it from GoDaddy or maybe from Route 53 of AWS. Okay, it's a DNS service. Okay, why it is 53? Also we need to discuss, because DNS runs at 53 port. Okay, there are how many ports in it in a server? Like around 12652 to the power 64. Correct? That much port is there, in which DNS uses 53 ports. So that is why route 53. So now any .com we will try to purchase, like lwplabs.com, something like that, where we will try to we will register it to the route 53, and then finally this will point to a load balancer. Load balancer will send request to web server and then the app server, and then it will get the database. The app server will fetch the data from the database and all those things. So this is like a simple architecture diagram which you all should know. Okay, a flow diagram, better we can say, not architecture diagram. It's a flow diagram, how a request flows from client machine to till the end to the database. So we will have to do this. Okay, this app server is the place where you will deploy things, or is this web server is the place where you will deploy through Jenkins. Okay, like if there is an HTML file, you will deploy here. If there is an Java or something like that, PHP. Okay, this app server is not always Java server. Okay, a lot of students will do this mistake when they go for interview. They will say, okay, app server means, they will think it is a Java server only. No, app server can be Python server. Okay, maybe you can install Python in your Linux machine. Okay, you will have a Linux machine where you will install Python, and that is your app server. Okay, it maybe you have installed a PHP in your server in a Linux machine. That's an app server. Okay,
Then you will
so
have zip files as artifact.
right. So whatever you can build through Jenkins. So basically, what exactly we are trying to explain, that we will try to build any app server that can be PHP, that can be Node.js, that can be Python, that can be Java. Java is little more complex, but then other things are like easy. Okay. And then what we can do, we can integrate it with database. Okay. And then it will fetch the data from the
Rahul, a few
database.
people have actually raised hand. I don't know if
Yeah,
their
yeah.
question is answered or not.
Yeah.
Yeah.
Go ahead. Yeah. So go ahead, ask your question, guys. I'm trying to search a CV so that I can show you like what exactly the CV will be sharing you maybe tomorrow. I want you all to join tomorrow so that I can share the CV on the WhatsApp group. Okay, we may create a WhatsApp group or we'll share it in this Zoom. So this CV will be aligned with the course curriculum, where it will be mentioned the project diagrams and the projects whatever you have worked on. Those projects only we will try to implement in our class, so that when you go for interview, whatever is
I
written
think
in
we
your
should
CV.
discuss the capstone project. I will, in detail, we will discuss tomorrow, but at least give them an idea. Like we are going to have to implement something called a capstone project. So for people for whom this word is new, capstone actually means, it refers to, hold on, let me get this. So you should be able to, at the end of the course, be able to do a capstone project on your own. Capstone project will mean, when you are able to do the capstone project, that means all the technologies that you have learned, they are all combined together. Okay, if you are able to do the capstone project, that means you have learned all the technologies, be it Linux, be it the operating systems, the Git, GitHub, Jenkins, Maven, whatever comes in between. Okay, together, combined, when you are able to do it. And here, this capstone project, you will have to use something called K8s, or in other words, Kubernetes. Okay, that is a absolute must. Kubernetes, Ansible, and Terraform. We will discuss this tomorrow, actually. We are running short of time, Rahul. So these three softwares you definitely need to know, but in order to be able to use these, you will need other softwares. Okay. So yeah, we will learn about these things gradually, but then your success will lie in the fact if you are able to implement this project. In that, you will be guided by me at a step by step. I will actually be implementing things real time and showing it to you. Now, don't get into a cycle where you are trying to learn all softwares. That is not possible. Okay. For example, for integration, we are going to use Jenkins. There is TeamCity, there is Travis CI, Circle CI. They all do the same thing. So it is pointless to initially try to learn all the softwares at the same time. That is just not possible in a limited time frame. Your learning is going to be a continuous, just like CI/CD is continuous, your learning is going to be continuous. Every software keeps getting updated in its version. It gets new features, older features get deprecated, and hence this process is continuous. Overall, you should be able to integrate the entire thing with a limited set of tools, and then be able to have a successful web application running, and automatically, which means basically the developers will just push the code using their local system, and it will reflect automatically in the website without any other intervention in any other software involved here. Numerous softwares that we are using. So that is the whole point of this course, so that you learn that process. It is a CI/CD project-based course. That's the idea here. So tomorrow I will give you more idea about this. I will have to discuss Kubernetes also, and I will get into further details with this. Kubernetes software. These softwares are absolute must. Kubernetes, Ansible, and Terraform. Cool. Yeah, Rahul, let them ask questions now. Let's see what their queries are.
I do have a question. Hello.
Please.
Yeah. Okay. So currently, like this course is totally